6 cores, 8 cores, 40 cores. Okay, well, maybe not the last one, but high CPU core counts are a major selling point for computers and even other electronics these days. Whether we're shopping online or talking to a worker, be at our local store. And the idea behind it is simple. Higher core counts suggest more power, kind of like impressive looking horsepower numbers on the car. Well, we probably seen advice around the web or hear from people that super high-end CPUs with many cores or hyper rating on something like Core i7 won't help much, if all for gaming. But why is that? Why are people averse to spending more on a more powerful CPU? So the answer lies in the concept called parallelization, which means splitting a program's workload across multiple processing cores so a computer can work on two different parts of the same load at the same time. For example, let's say we want to know what 5 times 4 times 3 times 2 is. A single core CPU would first multiply 5 times 4 to get 20, then multiply that times 3 to get 60, and so on and so forth. However, a dual core CPU could assign 5 times 4 to one core and 3 times 2 to the other, solve both problems at the same time, and multiply the results together, effectively saving time. Since it doesn't matter what order you execute the instructions in, since you are just telling the CPU to multiply numbers, this math problem is easy to parallelize. Now, although this is a really simple example, it does illustrate how certain programs can take advantage of multiple CPU cores because they require lots of number crunching that can be easily split up. We also have the homogeneous multi-core processor and heterogeneous multi-core processor.
How do we contrast between the homogeneous multi-core organization and the heterogeneous multi-core organization?
Yep, that's the question. First, we need to know the most noticeable difference for these two, which are homogeneous and heterogeneous. After that, we have to know what does the words really mean in general. For homogeneous, based on Oxford language means the same, kind, or alike. The synonym word for homogeneous is similar or matching, while for heterogeneous, the words means diverse in character or content, and the synonym for heterogeneous is varied or different. Before we go to the contrast between them in multi-core organization, let's have a very simple example for these two words. Here we have two different pictures. One is a cup of milk coffee and another one is a bowl of cereal with milk. Both of them contains milk, but one is milk plus coffee with its same composition, and another one is a milk plus cereal, which is different composition. Therefore, the instruction for them will also different. For the milk coffee, the instruction is only to drink, but the bowl of cereal is to eat and drink. So now we have a very simple diagram that portrays the difference between homogeneous and heterogeneous. The top diagram represents homogeneous multi-core organization where it is comprised of identical processor cores that support the same instruction set architecture. While the bottom diagram represents heterogeneous multi-core organization that comprised of non-identical processor cores that support different instruction set architecture. The following figure notionally shows the architecture of a system in which 14 software applications are allocated by a single host operating system to the cores in a homogeneous quad-core processor. In this architecture, there are three levels of cache, which are progressively larger but slower. L1, consisting of an instruction cache and a data cache, L2 and L3. Note that the L1 and L2 caches are local to a single core, whereas L3 is shared among all 4 cores. This figure shows how these 14 applications could be allocated to 4 different operating systems, which in turn are allocated to 4 different cores in a heterogeneous quad-core processor. From left to right, the cores include a general-purpose CPU running Windows, a GPU core running graphic-intensive applications on Linux, a DSP core running a real-time operating system (RTOS), and a high-performance core also running an RTOS. Okay, so the multi-core processor that I picked is Ryzen 7 2700X. Ryzen 7 2700X is a desktop processor type produced by AMD. The best clock frequency for this processor is 3700 MHz, but it can perform up to 4300 MHz due to turbo core technology, or we call it max boost. The Ryzen 7 2700X is the most high-end CPU from the new second generation Ryzen family, having 8 cores, and for this processor, the chip will include 3 cache levels. It has 4MB of memory for level 2 cache and 16MB for level 3 cache. Level 3 cache is specialized memory developed to improve the level 1 and level 2 cache performance. The more cache there is, the more data can be stored closer to the CPU. Ryzen CPU are built with CCX or Core Complex Modules. Each CCX has 4 processing cores, 512KB of level 2 cache memory for each core, and 8MB of level 3 shared cache. For the level 3 cache, also called as the last level cache, the memory is shared among cores. The Ryzen 7 2700X has simultaneous multi-threading. It has twice as many threads as it does cores, which are 8 cores to 16 threads. It lets each core handle 2 threads, thus each core acts as 2. It gives us around 30% performance boost at most. Remember to only turn this mode off if we need to present 8 threads to the system instead of 16.